This is the lesson over 8.3, Solving Systems of Equations by Elimination. So far we've learned how to solve systems of equations using graphing, and then we also learned how to do it algebraically using substitution. This is a second way to solve algebraically, and this way is called elimination. So what does that mean? What is elimination? So elimination is a method for solving a system of equations. And it's solving algebraically. So solving a system of equations by adding the equations, or adding or subtracting, but we're going to focus on adding to make it easier, adding the equations so that a variable eliminates. So we're going to talk a little bit more about what that means. So that a variable eliminates. Eliminate, what does that mean? Think of what elimination means in the real world. It means it goes away, it terminates, it ends, right? So it goes away, it eliminates, it's no longer there. So when we solved systems of equations using substitution, we combined those equations so that we would only have one type of variable in the equation, either just x or just y. It could be in multiple terms, but just x or just y. This method does that same thing by eliminating the variable. So you're going to see how that works here in a second. So let's just go ahead and go through one of the examples, and then we'll come back and we'll fill in the notes, okay? So solve the system of equations algebraically using elimination. So what we're going to do with these two equations is we're actually going to add them together. So we're going to put just a little bar here and a plus sign. And what we're going to do is we're going to add the left side of the equation to the left side of the equation and the right side to the right side. Wait, Miss Booten, how in the world can we do that when they're different things? We're adding 3x plus 3y to this side, but 6 to this side. What we do to one side, we have to do to the other. So how is that possible? Well, here's how that is possible. So let's take that first equation, 2x minus 3y equals 12. You're right, what I do to one side, I have to do to the other. So say if I wanted to add 5 to the left side, that's fine. It doesn't really help me solve this problem, but I can do it. But I'd have to add 5 to the other side as well, because what you do to one side, you have to do to the other. Okay, well maybe actually I don't want to add 5. Let's just add 6 to both sides. Again, that really doesn't help. But here's the thing. I've got a system of equations here. This is one of my equations, and this is my other equation. And in this other equation, I do have a 6 here, right? So if I add 6 to both sides, I still am going to have an equation that's true, but it's not going to help me. But watch what I can do. 6 is equal to x plus 3y. So instead of adding 6 to the left side, I'm going to add x plus 3y to the left side. So I actually am adding the same thing to both sides because look at this equation. X plus 3y is equal to 6. So I'm adding 6 to the right side and x plus 3y to the left side, but I'm actually adding the same thing because they're equal. They're the same thing. So I actually am adding the same thing to both sides because in this system of equations, x is equal to 6 is equal to x plus 3y. So I actually am adding the same thing on both sides. And if we were in class, I would have this on a note card, right? And I would flip this around, add 6 to both sides, flip it around. 6 and x plus 3y are the same thing. So I'm adding the same thing to both sides. They just look different. But according to my system, they are equal. So that's why we can add x plus 3y to the left side, but 6 to the right side because they're actually equal quantities. They're the same thing. So I am adding the same thing to both sides. All right, so let's go ahead and do that and see what happens. There's some magic that happens here. Well, it's not magic, but... All right, so when we add the left side to the left side and the right side to the right side, we want to make sure that we're only combining like terms, okay? So look how nicely it's stacked up, too. We've got like terms stacked on top of each other, which is awesome. So what's 2x plus x? That's 3x. And then what's negative 3y? This is minus 3y, so negative 3y plus 3y That's 0. That zeroes out. That variable eliminates. And that's what we wanted. Because now, look at this right side. 12 plus 6 is 18. Now we have an equation that only has one variable, so I can solve for it. And this is a really easy equation to solve too. So divide each side by 3, and we get x is equal to 6. Wow, how easy was that? Why didn't you show us this before, Miss Booten? Well, here's the deal. They're not always going to be set up like this. In this section, they are mostly set up really nicely for you. And what I mean by that is when you add, something is going to eliminate. But what if this wasn't a 3? What if this was like a 4? Then it would be a 1y here. And then adding the two equations together wouldn't have helped us at all. So we have to add with purpose. That's the biggest thing here. Add with purpose. Do not add the equations left side to right, left side and right side to right side unless something is going to eliminate. So in this case, it is going to eliminate because we have a negative 3y and a positive 3y. So that would eliminate the y variable. So you might be thinking, well, what do we do when it's not going to eliminate? That will come next section. So for right now, we're just trying to get the hang of how this works and why we can do it. Okay, now that we have x equal to 6, that's one of the variables, so we have to solve for the other variable. I have to solve for y. So how in the world do we do that? Well, it's the same exact thing as we did when we solved using substitution. And one thing I wanted to do at the beginning but forgot was to number those equations, okay? So we're going to treat it the rest of the way to solve the rest of the system and check. You're going to do it the exact same way as you did with substitution. So you get to pick either of these equations, plug in 6 for x, and solve for y. So I'm going to go ahead and choose equation number 2. And so I'm going to, instead of x, since my equation says x plus 3y equals 6, instead of x, I'm going to plug in 6. So we're going to say 6, and then write the rest of the equation, plus 3y equals 6, and then I'm going to solve. So we're going to subtract 6 from both sides, and then, hey, that's 0. But you have to write the 0, remember, because there's literally nothing else there. So 3y is equal to 0, and then, well, we got to finish solving, divide by 3, and 0 divided by 3 is 0. So it's okay for a variable to equal 0. That's all right. So y is equal to 0. Okay. So then again, like I said before, this is the same thing as substitution because we substituted 6 back in to find out our second variable. So now we have to solve, or we have to check. So we're going to check it in which equation? We used equation number 2 to solve for the second variable. So we're going to use equation number 1 to check. So we're going to say check, and we have to use equation number 1. So let's write that. So 2, and then instead of x, we said that x was 6, so we're going to plug in 6 for x, minus 3 times my y, which was 0, so that's going to be easy. And is that really equal to 12? So again, we have multiplication, multiplication, and subtraction. Order of operation says multiplication comes first. So we can't subtract these two numbers unless we know what two numbers we're subtracting. So we can do these at the same time. 2 times 6 is 12. 3 times 0 is 0, and we're subtracting those two numbers. And you should all know that 12 minus 0 is 12. So it works, and we're correct. So again, our final answer is going to be the x and y written as a coordinate point, because if we were to graph these two lines, this is where they'd intersect. So we write it as a coordinate point, so x comes first, so 6, 0. And again, you can use curly braces, which is also called a solution set, if you want as well. But for sure, so going great so far. But for sure, you need to have it written as a coordinate point. And that is our final answer, 6, 0. All right, so let's go back at the top and let's fill in some notes on like how we did that. All right, so once we add those equations together, so we added the equations together here, and what that did was it eliminated a variable. So after that was us combining the equations. So right here it says after combining the equations, the rest is the same as substitution. Is the same as solving using substitution. which is awesome. All right, so you will substitute. You will substitute the value of the first variable that you solved. So after you eliminate a variable, you solved the variable just like we eliminated y by adding, and then we solved for x here. Solve for x here. All right, and then you solve for into 1. So once we solve for that, we're going to substitute it into one of the original equations. This is really important, again, to stress that original, because like in next section, we're going to do stuff to the equations first before we add. And so always plug into the original equation, though, after you've solved for one of the variables. Into one of the original equations and solve for the second variable. And then we need to check your answer using the other equation. The other original equation again. All right, so I kind of already talked about this, but this is when you're adding equations, we need to add with purpose, okay? Don't just add if nothing nice is going to happen for us. There's no use adding if nothing eliminates, and we'll get to an equation, a system where that happens in this section. But it's still pretty straightforward, and the next section will deal with ones that you have to do more than just a little thing. All right, and so make sure you line up the equal signs, because that's something that really gets people here, is when you don't line up the equal signs. You have to line those up for sure. So like if in my original equation here in example 1, if the 3y was on the opposite side, you could not combine those because they're not on the same side of the equation. So you have to add left side to left side, right side to right side. So you have to line up those equal signs. Just because you've got a like term on the right side in the second equation with the left side on the first equation, that doesn't mean you can combine them left to left, right to right. So you'd have to rewrite if it wasn't lined up nicely. All right, left side, right side, right side. And then it would be nice if like terms were on the same side of the equation like I was just talking about. So example, x on the left side for both equations. And if that's not true, we need to rewrite it. So yeah. And then remember, you can eliminate either variable. In the first example we did, we eliminated y, but you can actually eliminate x too. In this one, it was set up nicely to eliminate for y, so there's no use in redoing anything to make x to be able to eliminate, but you could have eliminated x as well. All right, so let's do another example. Oops, I forgot to put this down here. Adding x plus 3y is the same thing as adding 6 because they are equal. All right, so let's go on to example number 2.